Welcome back, guys. We're on episode 3 of our Learning MonoGame series, where we're learning how to make a Geometry Wars clone following this very helpful Neon Vector XNA tutorial. This is episode 3, so if you're the first time coming to my channel, have a look at episode 1, which I'll put in the link up top now, as well as in the description. And we are following a particular tutorial here, so I'll put the link to this tutorial down in the description as well. Alright, or if you're just looking to figure out how to do some very simple collision, then you're also in the right place, because that's what we're looking at today. So in episode 2 we also looked at enemy classes and how to implement your enemy behavior. And now we're down on this page under collision detection. Alright, so let's get stuck right in. First off, the first couple of paragraphs in the tutorial say we're just going to be using very simple circular collision detection, where we're also going to just compare every entity against every other entity that currently exists in the frame. In the frame. And collision can get pretty hairy when you have more than one entity, and when it obviously you have to have more than one entity. But when you start to have like hundreds of entities on the screen, you might want to start looking at a little bit more complex techniques at dividing up the collision detection based on whatever's on the screen, right? Because it can get a little bit hairy once you get really crowded. And so you've got quad trees, sweep and prune, and BSB trees are the ones that the tutorial mentions. But for now, we're just going to implement the very simplest collision detection, and that's just comparing everything against everything else. Okay, so I went through this and I found it was actually not too difficult. There weren't really any gotchas, except for the one that I did for myself. And that was right here. So the first section goes through and says that we need to keep track of what entities are enemies and what entities are bullets, and not just... So at the moment we just have a entities list in our entity manager, and I'll just open up the code. So in the entity manager class, we have right at the top, before you write this up, you'd have just the entities list, which keeps track of all the entities on the screen. But we're also going to add the entities to their relevant entity type inside their own list as well. So you see we've now got enemies list to hold all enemy entities, and a bullets list to hold all bullets. And the reason why we have these two is because we want to handle the collisions between these things, and it's going to behave differently depending on what collides with what. So for example, an enemy colliding with another enemy, we want them to bounce off of each other. A bullet colliding with an entity, with an enemy, we want to have the bullet and the enemy both be destroyed. And when an enemy collides with the player, we want the player to be destroyed or killed. And all the other enemies on the screen to wipe the screen basically and restart the game. So in order to do that, we need to have these two lists, and in order to add the irrelevant entities to the relevant lists, we also have this add entity method inside the entity manager as well. So what this does is when a new entity is added, we call this add entity, and then add that entity as well as to the general entities list, where we keep track of all entities. We also add it to its relevant list type. So if it's a bullet, we add it to the bullets list, and if it's an enemy, we add it to the enemies list. And the only gotcha that I ran into was, see this add entity, we need to replace so at the moment, if you hadn't gone to this bit, at the moment it's just doing a entities.add, which obviously only adds the entity into... okay, so this is what you'd have here normally. So all this would do is add it just to the master entities list, but it won't add it to these two, and these two are required for your collision detection. So make sure you replace that line with your new add entity method. and you need to do that under the add inside Entity Manager, and you need to do that also in the update right here. So where you are interacting through all the entities in the added entities list. So you've got a couple of lists to manage here, right? But make sure you just replace those ones. Okay, save that change. Alright, what's next on the list? Alright, so we've got the next part of the tutorial is the IsColliding method, which also lives inside the Entity Manager. So let's have a look at it. IsColliding. Alright, here, IsColliding. So this method takes two entities. You can see here A and B. And then it compares them, and the idea is to return whether this current frame, whether these two entities are colliding with each other. And the way we do that is basically we just check if they're overlapping or not, right? So if they're overlapping, then they must be colliding. And all the entities that exist all have a radius that's set based on their image that's loaded when they are created, okay? So the way the math works is we add the two radiuses together, and then we return, and then we so we have the final radius, the radius of the both entities added up together, and then we compare that with the distance between the two entities. Okay, so the way that works, I had to draw this up. Okay, just to clear it in my mind. So let's say we've got one entity A, which has a radius of 5, and one entity B that has a radius of 5 as well. Nice and simple. The sum of their radii is 10, okay? And the distance at the moment, the distance between them is 15, okay? So are they colliding? No, they're not colliding, right? You can see that they're separate from each other. They're not colliding right now. And the maths also reflects that, right? So sum of radii is 10 and distance is 15, and so in this code here, so the sum of the radiuses is indeed less than the distance between them, and therefore we're going to return false here. Okay. Now, if they were colliding, so we'll just bring them together. So I'll just bring that guy over to there. Say just do a little bit of an overlap. The sum of the radii is still 10, right? Because the radius doesn't change, but the distance between them has changed, right? So that's not 15 anymore. That's probably something like 9 now. So distance is now distance between the two is taken from the center. So the center of the two entities, the distance is now 9. So what's this going to return? This is going to return true now, right? Because sum of radii is now greater than distance, which is exactly what we're doing here. So the distance between the two and the sum of the radii. And the only little funny thing here is instead of using distance, we're using distance squared. And in return, and because we're using distance squared, we also have to square the radiuses to keep it level. But it's exactly the same. There is the only reason why we're doing distance squared is because it's easier to compute than actually finding the actual distance, right? So just this little efficiency thing that the author of the tutorial has informed us about and implemented. Alright, so the next part is our handle collision. And this is a handle collision between enemies, so only if an enemy is colliding with another enemy, right? So let's have a look at how this works in our code. So this exists inside your enemy class, and it's just a method, another public method inside the enemy class. And what we've got here is first we're going to figure out the direction that we want this enemy to move in. We're not going to control the other enemy, right? So this enemy. And the way to figure that out is you go the position of this enemy minus the position of the other enemy, and that will that will create a vector that's pointing this enemy away from the other enemy, or away from the point of collision, basically. So that's why we've got that direction. And then you can see a little bit of maths here. What we're doing is we're applying a change to the velocity using that direction. So we're going to move it in the direction away from the other enemy, basically, so we get that bounce. And we're going to apply a change to that velocity in the other opposite direction of the collision. And it's going to, that change in velocity or acceleration is going to be greater at the point of impact or just after impact, so when they're next to each other, and then as they separate, that acceleration is going to decrease and decrease and decrease until it's negligible. Okay, so we want to have like a nice bounce initially and then just dissipate to nothing. Okay, so that's that one. Hopefully that makes sense. Alright, so the next part, we want to put a couple of helper methods inside the player class, just to handle when the player gets bumps into an enemy and then we want the player to die. Okay, so the way that's implemented is we've got two new member classes, and that is we're going to have a boolean that returns whether the player is alive or not, and that whether it's alive or not is going to depend on if there's any respawn frames on the player. And so we've got this frames until respawn. And this is where the frames until respawn actually get a value. So initially they start with a 0 value. And then when there's a collision with an enemy, we're going to call this kill method on the player. And that's going to put a number into the frames until respawn. And then in turn, that's going to change isDead to true. And if isDead is true, so under the player's update method, now let's go ahead and go to the code. So under the player's update method, where is it? Oh, it's here. Yeah, under the player's update method, we have the isDead, and we're going to use isDead. So if he is dead, that must mean that there is some time on the respawn timer. So we just subtract from that every update loop until isDead becomes false and it becomes alive again, and then the player respawns, right? Because he's not dead. Also, if isDead is true under the draw, we're also overriding the draw method, because prior to this, we were just inheriting draw from the entity parent class. Now we are doing, we're overriding it, and we're only running the draw method if the player is dead function is false. So if the player is alive, right? Okay, and this is the only other, this is one little tricky bit, is if you don't know how to call a method or a variable from a parent class, the way you do it is with base. So base.draw is pulling out the parent, the entity class, is pulling out this method basically. Just so we don't have to rewrite all of that. We can just use the one that's already in the parent class. Okay. So obviously, the player ship inherits from the entity class. Just better mention that just in case that confuses anyone. Okay, so, alright, and then the last bit, now that the player's all set up, all the behavior for collisions is set up, now we can just create this HandleCollisions method, and we're going to create that inside the entity manager. Let's jump over the entity manager. And under HandleCollisions, the first section here is to handle collisions between enemies, so enemy and another enemy. So we've got two for loops here. We've got the first for loop starts with, iterates through every enemy inside the enemies list. And the second for loop iterates through every enemy inside the enemies list as well, except we're going to start with the next enemy along in the list. So we start with enemy 1, and then we compare that to enemy 2 that is in the enemies list, and we see if they're colliding, so is colliding. And then if they are colliding, then we run the HandleCollision on both of the enemy entities, so they'll bounce away from each other, which you saw earlier. And then we just keep iterating through, so for enemy 1 is compared against enemy 2, 3, 4, 5, 6, 7, however many enemies there are. And then on the next loop of this one, we go from enemy 2 and we combine that with, we compare that with enemy 3, see that, enemy plus 1. So enemy 3, 4, 5, 6, 7, and then you just keep going until every enemy has been compared against every other enemy. Okay? So that's what the 2 for loops are for. And then the next one is between bullets and enemies. So we get, same thing basically, we get every bullet that exists and every enemy that exists, and we compare them to one another. And then if they are colliding, we, on the enemy that it's colliding with, we run the was shot. And I don't think I showed you that, but if we go to the enemy, there is a was shot there, and all that does is set is expired to true, which kills the enemy, right? And then we've got the bullets, and then we just basically, it's basically a was shot, right? We just make the bullet disappear. I think later down we probably want the enemies to explode or something, and that's why the was shot is there for enemies. Whereas bullets probably would just have them disappear. Or I guess you could do something special if you wanted. Anyway, next one is if a enemy collides with a player. So we go through all the enemies in the enemies list, and then we check if that enemy is active. And if it is active, then we also check if it's colliding with the player. So if it is colliding with the player and it is active, then we run the player.kill method on the player instance that's being used, and that just kills the player, so it won't be drawn anymore until the respawn timer ticks over. And we also run the was shot method on every enemy that exists. So if you wanted enemies to keep floating around, you wouldn't have this. But in this case, and following the tutorial directly with what he says, we're going to wipe the screen of all the enemies. So you can see this, it's, we're using this library called link. So if you look at the top, we've got system.link. And what that allows you to do is, through a list, which is this enemies list, you can do this very quick for each command. You can also do it the long way. And we're going to run the enemy.wasShot command on all, method on all of the enemies that exist, which basically wipes the screen clean. And then there's nothing on the screen, right? So we just break out of the loop. We don't really need to do anything else. Don't need to keep iterating through the enemies list because there aren't any. And yeah, I think that's it. Let's have a look. Yeah, I did want to show you. So right at the end here, it's got call this method from the update immediately after setting update to true, is updating to true. So we're talking about the HandleCollisions method. And then under update, just after is updating to true, that's when you want to call it. Okay? If you don't have that line in, or you just missed the bottom line, you're like, oh yeah, it's finished, let's check it out. None of your collisions are going to apply. So even though there are collisions happening, none of the behaviors are going to be applied. So make sure you have that put into your update loop under your entity manager class. All right, that was a lot. That was a lot, guys, but it was all pretty simple stuff. So hopefully that helps you out. And that's pretty much the tutorial. But as I always like to do is after writing a whole bunch of code, I want to get rewarded with looking at how it behaves. So if you want to do the same, we'll just jump into your game root. And in my code, I've just got one wanderer here. I'm going to add in a couple more wanderers. So, yep. So this is just for testing, guys. Basically, under your initialize, if you want to test all this collision stuff out, all you have to do is in the entity manager, run the add method and then add a bunch of enemies in. So in this case, I'm just adding some wanderers. Let's go 1, 2, 3, 4, 5. We'll just add them all into a line. And just for good measure, let's add in a couple of the seekers. So create seeker. I think seekers have a better chance of running into each other, so we can check on that that enemy to enemy collision. So put that 600, 700. Okay, let's give that a whirl. And I've got the controller here as well, if you can see it. It runs better on the controller. There's a little bug. Okay, here we go. Oh, I've just shot them all. Hang on, let's start that again. I want to see that properly. Alright, start the mouse down here this time. Alright, look at that. Oh, I don't know if they're colliding with one another. Let's see if we can run them into... Oh, crap. Okay, let's try that again. One more time. Alright. Alright, these seagulls are pretty quick, aren't they? Don't know if that enemy-to-enemy collision is working quite yet, but I did test that out before, and I think that was working. I was using bigger objects, and I probably need to apply a larger acceleration on the enemies. So if you are looking at my code, I would say the problem is here. So you're only applying 10, and you'll also notice that my acceleration, so anything to do with time, you have to worry about your frame method. So if you're doing a fixed step frame rate, this would probably work okay. But I'm using a variable step frame rate, so this probably needs to be multiplied by time, and this number needs to be increased significantly. Otherwise, like 10 pixels per update, it's not really going to affect it very much. So the only way I can do that is when we do the next part, which is in the enemy spawner, which gets created which gives me access to the game time, and then we can apply that. I've got the issue in the GitHub. So if you look through all my code, you'll notice that there's heaps of comments throughout. There's probably more comments than there is actual code. The reason why I do that is so that it's easier for me to understand what's happening in the code, and also hopefully to help you guys out as well. So I've got all of the project all split up in separate branches, separated into episodes along this series. So please take a look at the description. I'll put a link to the GitHub where you can clone it from there. And yeah, so that's it, guys. Next episode, we're going to be looking at the enemy spawner, and maybe scoring and lives as well. I don't know if I'll do them in separate videos or not. But yeah, that's it. Thank you very much for watching, guys. Cheers.